I'm here today from Microsoft. I work here within generative AI, and I am actually here in order to talk to you all about prompt engineering and prompt hacking. And really, I want to get down to the bits of what these things are, agnostic of any particular uh, company technology, but really just talk to you about these concepts so that you understand what they mean in your business. So that being said, let's start by explaining why this is important. When we talk about prompt engineering, why does that even matter? Well, one of the leading members of GPT, as you may know, is Andre Karpathy. On January 24th, 2023, so last year, he said the hottest new programming language is English. This has changed the game, folks. A lot of us were very clear about, programming, human-computer interaction all these years, and now that we are now programming in English, things change quite a bit. And so that being the case, the avenue that we choose to get there is actually through prompt engineering. Um, where this comes into play is whenever you are using a GPT model, you'll find that a lot of what it does is task based. I'm sure folks have already gone into what prompts are, what GPT is, and so I'll let other speakers talk about that. But today I'm deep diving into how do you really optimize for the language that you use with GPT so that you can get the outcomes you want. And so, whenever we think about a particular task, it might be, for example, summarization. Um, GPT may fail. And so at that time, what do you do? Well, you could search for a better prompt that elicits a more reliable answer, right? So this is the first category, which is perhaps give clear instructions, split complex tasks into simpler tasks, right? Those are the things that kind of come to mind here. You could also invest in thousands of examples to fine tune a custom model, and that is not cheap. There's a lot of GPUs that get utilized there. Now, the other thing that we've seen people do is assume the model is incapable of the task and move on as well, which is somewhat like giving up. Well, there's no simple answer on what you should do when GPT fails on a task. Getting the model to reason and provide that desired response is an art in itself. So there's a couple of things you could do. Maybe you've heard of these terms of one-shot or few-shot learning, where you give the model examples, maybe one example of how it's done, just like teaching a baby how to walk or how to eat, things like that, right? You have to give it examples. You got to show it how to do it. Even same thing with training a dog, for example. So those are what one shot or few shot learning would entail. Now, whenever you think about a model failing on a task, my guess is that a lot of work that we're going to do in this space as experts is to master this particular art, right? And come up with techniques to help basically our customers use these models to derive the outcome desired before getting into expensive fine-tuning solutions. And so today I want to walk you through or talk about some of these techniques. The beauty of these models is that we don't have to tinker with code. We can simply use natural language, right, through prompt engineering to guide the model to reason through the human partnership approach. So that being the case, we can talk a little bit about prompt chaining today. Part of what needs to happen in many of the use cases we have is for generative AI is you may think about how can I extract the main entities so I at least have context of what I'm dealing with, summarize this information, and then provide some insight on top of that, right? That's the basic workflow that you will see human beings use. And so in this case, what we're finding is that we have a particular task we've assigned GPT. Hey, the new iPhone model is set to be released next month. It's been highly anticipated by Apple fans and is expected to feature a large screen and improved camera. So in this case, what we want the model to extract is, okay, we're talking about an iPhone. We know it's talking about a product, and then specifically the brand of Apple, and that's the organization that we need to go look through in our data. The next thing that will chain to that is the next step, which is summarization. So tell me a little bit about, summarize the product information for me. And so it'll go ahead and do that. We know generally about iPhones, and then provide some insight, right? Some sentiment or some sort of, where's the white space in a sense, right? Some discovery there. And so generally the sentiment there is positive. So this is what is considered prompt chaining. So you can basically bring these tasks together. It is one of the aspects. So if there is if one of these tasks is not doing well, we need to figure out which is that task and where's the bottleneck, so we can figure it out. The next thing that we'll do, right, when we think about summarization, let's deep dive into that. We are ingesting a large text in this case. And what we want it to do is summarize a particular text. And it's going to do that through chunking, breaking it down into smaller chunks, right? And so it's able to go ahead and provide a summary of that particular large document broken up into different chunks and provide summaries of each. And it's able to identify the topic as well. What are we dealing with here? And so all these summaries of each of those chunks are passed to GPT to summarize a second round of summarization. And then the sum of the summaries, we ask it to fit within a token limit. Those output tokens, by the way, is where your money is going. So generally you want to have limits there. When you don't have limits there, you would be at a disadvantage in a sense for not seeing if there is a denial of service attack going on, where it's just the GPT is just spitting out large responses. So that is something to kind of keep in mind. The next thing that you would do is start on the reasoning journey. As a human, what we would look at doing is take in, the prompt. So ingest the prompt, for example, on the left-hand side here, we're looking at Roger has 5 tennis balls, for example. He buys 2 more cans of tennis balls. Each has 3 tennis balls. How many tennis balls does he have now? The answer is 11. And then we kind of start to provide it more information, which is, okay, the cafeteria has 23 apples, tennis balls to apples. If they use 20 to make lunch and bought 6 more, how many do they have? The answer is 27, right? So this is a very confusing situation, right? Where it's providing the answer is 27. It didn't really think through the difference between tennis balls and apples. It's just kind of looking at numbers. Which is strange. So now this becomes very important for us to provide that reasoning, that context, okay? That in this case, we need to have a clear picture of what is the end result we're trying to get to. And so here, let's try this again. We start with the same concept, right? Which is Roger has 5 tennis balls. We go through that example. And so the answer is 11, which is fine. The cafeteria has 23 apples, right? We go through this particular prompt as well. Now it's able to understand the cafeteria had 23 apples originally, right? They used 20 to make lunch. So now they have, 23 minus 20, which is 3. And they bought 6 more apples, so now they have 9. So the answer is actually 9, right? It's very easy on this side to get it confused between the numbers. Here, you have to break it down, right? you have to break down the task for the model to read it properly. And that is what is considered the chain of thought. Okay. So here, let's look at this in a deeper way. We need to improve the reliability of our answers. And so one way to do that is to prompt the model to gradually reason out the answer rather than jumping immediately to the final answer. One of the ways you can do this is actually ask GPT to explain the steps that it took to get there so that it's actually transparent to you. You would be surprised at that point when you ask GPT to do that, what kind of systems, names, and details it will divulge at that point in order to get to transparency, but at the same time also poses a security risk. But that the idea of having the prompt gradually reason over the answer, in a sense, thinking out loud, the model can be far more likely to arrive at the correct answer. And so that's called chain of thought. It's a very powerful technique because it's used to provide model explainability. Because if those of us who have worked with GPT-3 at one point or other, it was seen as a black box model. And that doesn't provide you a lot of control either. But it can help the model reason and arrive at the desired output by simply just telling the model to think step by step, right? So, this is an example of a before and after here, where if the model rushes, it's actually getting to, in a sense, the wrong answer. And so that's what this is showing. So there are ways you can use chain of thought for reasoning to get to the correct answer. Generally, we know GPT is, in a sense, a language completion model, text completion model. And, mathematics is, it can come with its own challenges when we do math calculations with it. And so here, what we're showing is, there are options that exist for us in order to be able to use chain of thought prompting for reasoning. On the left-hand side, we will do reason extraction first. And so we provide a particular question, and it's able to kind of think step by step, explain the calculation. In 1 minute, Joe throws 25 punches. In 3 minutes, that should amount to 75. In 5, it should be 375, right? But now, if you ask it to kind of go through this in detail, step by step, we start to see something interesting. In this case, one approach would be, can we combine chain of thought and prompt chaining so that the model can derive the answer that we want? That's what we're trying to go after. So in this example, what you're seeing is you're using chain of thought to extract the reasoning behind the problem and using prompt chaining to provide the same reasoning for a similar problem. So generally, we use this when we're doing math or arithmetic or deriving logic. And in fact, the author of this technique benchmarked this approach, and the results were astonishing. It actually quadrupled accuracy from 18 to 79%. It was most helpful for multi-step arithmetic problems, symbolic reasoning problems, strategy problems, and other kind of logic and reasoning problems. But that's the key thing here is, can we combine chain of thought and prompt chaining both in order to kind of get that step-by-step explanation, right? That's what we're really after in this case. So, another one of the things we can do is use few shot prompting, okay, which is providing a few examples of how to do this particular mathematic and to get to this answer, to kind of reason mathematically through those reasoning chains. And so, here you can start to see that you can derive the chain of thought through these prompts. Um, for example, we kind of talked through a free response in the beginning when we talked about the tennis balls example, the answer being 11. So that's a free response math word problem. Another type of problem we can use is or we can apply this to is a strategy question and answer, right? Yes or no, would a pair sink in the water, right? And so how do you reason through that, right? Um, Instructing a robot is another type of question we can apply this to, where you ask essentially technology to say, well, how would you bring me something that isn't a fruit? And so you're asking the model to reason through a plan. Um, and so developing plans and being transparent about the steps in the plan are allow you to kind of trace back how it was able to get there. So this is another technique that we can use to create more transparency. We can apply similarly as we did the math word problem. We can do that for multiple choice. We can do that for date understanding, last letter concatenation. There's a lot of different things we could do. Even sports understanding, where a particular player was caught the screen pass in the NFC Championship. Is that even plausible? And in this case, it was able to identify, okay, NFC is part of American football, not soccer, right? So make sure the context is there. Common sense questions. This is, I think, at a case-by-case basis, I would say. But in this case, it's able to reason through some common sense as well as state tracking of coin flips, which is all statistical. So a lot of different things we can apply this to. And we can bear the fruit of it. The next thing we can do is selection inference prompting. Because chain of thought, it's not 100% accurate. It can lead to wrong results at times, especially when it's struggling when examples are short. And when the examples are short, but the task is long. So sometimes as a human, you don't know really how to solve the problem yourself. So one interesting trick that we can use, or one approach or technique, is to have the model decompose the task into smaller tasks and figure it out on its own. This allows the model to reason along the way and can lead to much better results. And this is what we call selection inference prompting. And so this is really just chunking it into 3 different tasks, into smaller tasks. And you can imagine it all has to kind of come together at the end of the day in order to get to the right answer. And so one of the things that you should be, that should come to mind as well, there's a little bit of obviously there's a decomposition required, but it's also somewhat of a tracking the state of the answer in each of these steps that is involved here, which is very interesting. And it actually lends itself to a lot of agentic workloads. That's why a lot of offline processes, for example, are being discussed right now in these days, if you've heard about things like autogen. So that's where this is coming from somewhat. So taking a step back, one of the questions we get asked quite a bit is, well, what's the difference between prompt engineering versus fine tuning? And it is an important question because there's a lot of, when you think about fine tuning, there's a massive cost involved. So let's take a step back and ask, well, what is prompt engineering in the first place? It's a concept in natural language processing that involves embedding descriptions of the tasks in the input to prompt the model to output the desired results. And that prompt typically includes problem descriptions, instructions on how to solve the problem, examples of correct problem, and solution pairs. This is also where, if you think about system prompts, you can include prompts around, content moderation. Establish those guardrails. What is safe? What is not? For the model to do, what persona do you want it to imitate? All of those things. right? And so let's talk about an example. Let's talk about a topic classifier. In this case, what we want to do is craft a topic classifier using prompt engineering to help an insurance company sort incoming customer questions. This prompt composes of 3 different parts: different instructions, examples, and tasks as marked by different colors. So let's look at them one by one. Let's talk about instructions. The first one in blue on the top. The instructions contain high-level and detailed guidelines that you can see here of what we're asking the model to do. The high-level guidance is to classify the customer's question. And basically there's classify between categories 1 to 3. And what that is saying is that we want to restrict the output to be between 1 and 3. So that we're trying to make sense of it, right? Then the detailed guidelines take it one step further. They basically map each topic to a number. So for example, choose number 1 for auto insurance, 2 for flood insurance, 3 for irrelevant questions. Now on the examples side, which is this teal blue color, the second one here, this prompt has 1 example for each topic. And so in practice, you can feel free to add as many examples if you wished for each topic. But note that the order of the examples here matters. So you want to iterate and find the best order that you would want on these questions that you want to pose.
Hey, Priya?
Yes.
Priya, we've got about 2 minutes. This is
Okay.
critically important. If you could just be aware of that, that would be great.
I will wrap up in a few minutes then. This last part is the task and prompting answer. So the incoming customer question will be inserted here, okay, following the same format as the previous examples the model has seen. That last sentence, the model basically gives the last sentence prompt that the model is given provides actually the answer, right, for the last question. That's generally the order that it'll take. So that being said, I will, there's some examples here of 0-shot and few-shot prompting. Basically, it's the number of examples you give it. You can play with this, by the way, in Azure OpenAI Studio. Here's some, as I wrap up here, here's some few examples. I just have a couple more slides to go. Here's some examples on how we can reduce hallucinations using prompt engineering, which is a massive issue that exists within GPT, is reducing hallucinations. The first technique is to include instructions, specifically asking the model not to make up stuff and stay with the facts, right? Restriction is the second one. So you can actually call out restrictions useful for classification, restrict the model to choose from a confined list instead of having it generate free-form category names. Third, we talked about chain of thought style of instructions, which means we just add, please solve the problem step by step in the prompt, right? That's all we need to do. The fourth technique is to repeat the most important instruction to help the model following it. And the fifth technique here is to position the most important instructions in the last to make use of the latency effect. There's a high-level list and not complete in practice. Each use case is different, so you'll have to experiment with which style works for you. But these are some things that you can try today to get things going. Fine-tuning on its own is utilizing transfer learning, and it's taking a model that already has been trained and tune it using a label data set. That label part is where a lot of the time and money comes in for a specific task. So don't feel that you need to use fine-tuning for everything. There are certain use cases here that I'm highlighting. That will be super important. If it's very domain specific or latency is very important, that's critical as the top metric, then something to look into, or you have very high quality data and ground truth already there. Those are some reasons to use fine-tuning, but it is expensive. This is my last slide here. Here's some general recommendations. Um, you, as much as possible, would want to use general foundational models that are provided out of the box by OpenAI, and try different prompts, do prompt engineering. It'll be cost per performance. It'll be a better option for you. Secondly, try to use similarity search. It actually exists in AI search to create dynamic prompts that can be beneficial in cases where total content is way too extensive, right? So here you're only using the most pertinent information. Um, if you're using fine tuning, use the highest quality data set. It's pretty expensive otherwise, and monitor it. Very important. Same as in traditional ML models, monitor for drift, things of that nature, overfitting, underfitting. And lastly, experiment with prompt engineering on advanced models and use tuning less. Try to compare the performance metrics and operational latency and cost. That being the case, folks, I really appreciate your time today. And if you have any questions, feel free to reach out to me. I'll put my email in the chat here for folks to reach out to me. And this was a high-level overview. I can go through, I think prompt hacking and things and prompt shields next time in greater detail. Thank you, everybody.